Week 7, Introduction to K-means Clustering with the Mall Customers Dataset. In this lesson, we will explore how K-means clustering works and apply it to real data. We will use the Mall Customers Dataset to find patterns in how customers behave. Clustering is a key task in data mining for revealing groups that are not easily seen just by looking. Running the cell now. What is clustering? Clustering is a way to group similar data points together, based only on their features. It is a type of unsupervised learning, meaning we do not give the computer labels or answers. Instead, the computer tries to find its own groups within the data. Running the cell now. Let us start by making sure no warnings bother us as we work. We load Python's warning tools. Import NumPy as NP. We set the random seed to 42 for reproducibility. We turn off all warnings. This keeps our notebook output clean. This comment shows that we want to avoid warning messages. Running the cell now. Here, the code sets up the environment by fixing the random seed and suppressing warnings to ensure reproducible and clean output throughout the clustering lesson. While this step doesn't produce direct output, it's crucial for consistent results when we later run clustering algorithms on our data. This preparation helps us focus on the patterns and groupings that emerge, without distractions from random variations or technical warnings. Let us prepare our data. This is the data setup step for the Mall Customers dataset. We import pandas, a tool that helps us work with tables. We set the dataset URL and point pandas to it. We read the CSV file from the internet into a pandas data frame. We print the shape. This tells us how many rows and columns the data has. We print the first 3 rows of the data. This helps us check how it looks. Running the cell now. This output confirms we have 200 customer records with 5 columns each, including key features like age, annual income, and spending score. Notice the variation in these features across the first 3 customers, which sets the stage for clustering by grouping customers with similar behaviors. This initial data glimpse is crucial for understanding what the clustering algorithm will use to find natural groupings without any pre-labeled categories. Exploring our data. This dataset shows different people who shop at a mall. Each customer has several features: ID, gender, age, annual income, and spending score. Spending score is a value assigned by the mall to rank how much they spend. Our job will be to find groups of customers who behave alike. Running the cell now. Let us make sure our data does not have any missing parts. Now we check for missing values in the data. Printing this helps us see if we are missing any information for any customer. Running the cell now. This output shows that there are no missing values in any columns of our mall customer dataset, which is important for ensuring data quality before analysis. Notice that each feature, customer ID, gender, age, annual income, and spending score, has 0 missing entries, meaning our dataset is complete and reliable for the next steps of exploration. This check helps us confirm that no additional data cleaning is needed regarding null values. Try checking missing values with other datasets too. Let us learn a bit more about our numbers. We ask pandas to give us quick statistics for the numerical columns. It shows us, for example, the mean age and the range of incomes. Running the cell now. This summary shows key statistics for the customer's age, annual income, and spending score, helping us understand the distribution and range in our dataset. Notice that the average age is about 39 years, while annual income varies widely from 15K to 137K, and spending scores span nearly the full scale from 1 to 99. These insights set the stage for deeper exploration of customer segments based on their income and spending behavior. Data preprocessing. K-means can only work with numbers. We will choose only the features we want, and turn them into numbers if needed. Running the cell now. It is time to pick out just the columns we want the algorithm to look at. Here, we choose age, annual income, and spending score to use in clustering. We make a new table with only these features. This helps the algorithm focus on what matters. Running the cell now. Here, we selected 3 numerical features, age, annual income, and spending score, to use for clustering. This step ensures that the data fed into k-means is purely numeric, which is crucial because the algorithm cannot process non-numeric data. Notice how we focus on just these relevant columns to prepare the data for effective clustering. Let us take a look at what the data looks like on a chart. We load tools for plotting graphs. We make a scatter plot using annual income and spending score for all customers. Dots show where each customer falls on these values. We label the x-axis for annual income. We label the y-axis for spending score. We give our chart a title so it is clear what we are looking at. We show the scatter plot. This helps us look for possible groups. Running the cell now. This scatter plot shows how customers are distributed based on their annual income and spending score, with each point representing a customer. Notice the spread and any visible groups, which hints at how k-means might cluster similar customers. This visualization helps us understand the numeric features selected for clustering and confirms they are appropriate inputs for k-means. Can you imagine how you might group dots by eye? Scaling our data. Clustering often works better if each feature has the same scale. We will use a tool to make sure each number is on a similar scale. Running the cell now. Let us make sure the numbers are all on a friendly scale for the algorithm. We bring in a scaling tool from scikit-learn. We create a scalar object. We fit the scalar to our data and transform it, so the features now have similar ranges around 0. Running the cell now. Here, the code applies standard scaling to the data set, transforming each feature to have a mean of 0 and a standard deviation of 1. Although there's no printed output, this step is crucial because it ensures all features contribute equally to clustering, preventing variables with larger scales from dominating the analysis. This scaling sets the foundation for more effective and balanced clustering results. What is k-means? K-means is an algorithm that puts data into k-groups or clusters. It works by picking k starting points, then moving them to better spots until the groups are clear. You have to pick how many groups, k, you want to start with. Running the cell now. We will try making 3 groups of customers. Now, we create a k-means object and set k to 3. We import k-means from scikit-learn. We set the number of clusters to 3. We set a seed for random numbers, so we get the same results each time. We fit the k-means algorithm on our scale data. It learns which points belong together. After fitting, each customer has a group label. We print the group labels for the first 10 customers. This helps us check what the model found. Running the cell now. The output shows the first 10 cluster labels assigned by k-means when grouping the data into 3 clusters. Notice how each number, 0 or 2, represents a cluster, indicating which group each data point belongs to. This demonstrates how k-means segments the dataset into distinct groups based on the algorithm's optimization. Let us attach the group label to each customer. We make a new column called cluster in our data. We fill this column with each customer group label. We print the first 10 customer IDs and their clusters. This lets us see who is in each group. Running the cell now. Here, we see the first 10 customers labeled with their assigned cluster from the k-means algorithm. Notice how many customers are grouped into cluster 2, indicating a larger or more common group. This output helps us verify that the clustering process has successfully segmented the data by attaching meaningful cluster labels to each customer. Now, let us see the groups on a chart. We make a bigger figure for better viewing. We scatter the annual income versus spending score, but now we color by cluster label. Each color shows one of our customer groups. We label the x-axis with annual income. We label the y-axis with spending score. The title helps remind us this shows k-means clusters. A color bar helps us see which color means which group. We show the final scatter plot with clusters divided by color. Running the cell now. This scatter plot shows customers grouped into distinct clusters based on their annual income and spending score, with each color representing a different cluster identified by k-means. Notice how the data points naturally form separate groups, illustrating how the algorithm effectively partitions customers into segments with similar purchasing behaviors. This visualization helps us understand the outcome of k-means clustering by clearly showing the distribution and separation of clusters. Try changing the number of clusters and see what happens. How do we pick the best number of groups? Let us use a simple method called the elbow method. We make a list to store inertia, which is a measure of how tight the groups are. We set a range for k, from 1 up to 10. We loop over the values of k we want to test. For each k, we create a k-means object. We fit the algorithm to our data for that k. We add the inertia for that k to the list. Inertia tells us how far points in a cluster are from the center of that group. We plot the values of inertia against the values of k. We label the x-axis as number of clusters. We label the y-axis as inertia. The title tells us we are using the elbow method. We show the plot. We look for the point where the drop in inertia slows down. That is usually the best k. Running the cell now. This plot shows how inertia, which measures cluster tightness, decreases as we increase the number of clusters k from 1 to 10. Notice that elbow point where the rate of decrease sharply slows. This suggests an optimal k value that balances cluster compactness with simplicity. The code helps us choose the best number of clusters before actually running k-means. Let us find out what makes each group unique. This comment indicates that the following code summarizes the characteristics of each cluster. We group the data by the cluster column and calculate the mean values of age, annual income, and spending score for each cluster. We print the summary so we can see the average attributes for each cluster and understand their differences. Running the cell now. This output summarizes the average age, annual income, and spending score for each cluster formed by k-means. Notice how each cluster represents a distinct group. Cluster 0 has older individuals with moderate income and low spending, Cluster 1 includes younger, high-income, high-spending customers, and Cluster 2 has the youngest group with lower income and medium spending. This helps us understand how k-means segments the data into meaningful customer profiles based on these features. Practice. Try it yourself. Change the number of clusters to 4 or 5 and run the k-means steps again. Which groups can you see in your results? Running the cell now. Share your findings or screenshots in the YouTube comments below. Let us see what happens if we do not scale our data before clustering. This line poses a question about the effect of skipping the scaling step before clustering. We fit the k-means model to the data without scaling, specifying 3 clusters and a fixed random seed. We extract the cluster labels assigned by the k-means model to each data point. We plot a scatter plot of the 2 features, coloring points according to their cluster labels using the plasma color map. This adds a label to the x-axis representing annual income in thousands of dollars. This adds a label to the y-axis representing the spending score ranging from 1 to 100. We set a title to indicate that this plot represents k-means clustering done without scaling the data. A color bar is added to link cluster label numbers to the colors in the scatter plot. Finally, we display the scatter plot so we can visually inspect the clustering results and compare them to previous scaled results. Running the cell now. This scatter plot shows the clusters formed by k-means without scaling the features first, indicated by the color grouping of points based on their cluster labels. Notice how the clusters may appear uneven or biased because the variables have different scales, affecting the distance calculations. This highlights why feature scaling is important before clustering to ensure meaningful, balanced groupings. Did you see a big difference? Why do you think scaling matters? Recap what we learned. Today we learned how to use k-means clustering on customer data. We saw how scaling and picking k are both important. Using k-means, we found natural customer groups and could start to see who spends differently in the mall. Running the cell now. Next steps. Try playing with different features or your own datasets. Share your results and ideas in the comments. Remember to subscribe for more beginner-friendly data mining tutorials. Running the cell now.